Hi everyone, what's up? Welcome back to my tutorial channel. Today I would like to start my first lesson in the series of exam IFM, Investment and Financial Market. And the first lesson today I'm going to focus on mean variance of the portfolio theory. So in this lesson I'm first show you why we have to learn mean and variance and how to compute mean, variance, and volatility. And I'm going to go over some practice. So first, why do we have to learn mean and variance? Usually the investors want higher expected return for accepting the risk of an investment as losing money. In particular, given a set of investments with the same expected return, investors will choose the least risky investment. The same expected return, that means the same mean. Here the mean is the expected return of the investments. And we use the volatility to pick the least risky investment. And basically volatility here is just the square root of the variance. So I repeat, the expected return is the mean. And the volatility is the square root of the variance. And volatility is a tool to pick the least risky investment. So let's learn how to compute the mean. Given RI is the effective annual rate in returns of an investment in year I. To estimate the future returns, we use arithmetic average. That means we take the sum of the n years effective annual rate and then divide it by n. We use ER as the expected return, and R bar is the mean. See that? So these two have the same meaning, they just different notation. And we use summation of RI over n. So this is for the future returns. Now for the past performance of the stock, we use geometric average. And we can follow this formula. Sn over S0 is equal to 1 plus I, the whole thing to the n. Remember in the exam IFM, financial mathematics, we learned that suppose we have the effective annual rate I, interest I. This is a fixed number. Then after n years, the future value of S0 is S0 times 1 plus I to the n. So the ratio at n over S0 is just 1 plus I, the whole thing to the n. This is from exam IFM. So that's how we compute the mean. Now for variance and volatilities. First, variance. The variance is notated by sigma square of R or VAR of R. VAR means variance. And the way we compute it is we take summation of Ri, subtract R bar, whole square over n minus 1. Here R bar is the mean, the expected value. And here we use symbol variance, that's why we divide by n minus 1 instead of n. This is basic numeric summaries of data set and statistics. And the volatility is just the square root of it. So VOL means volatility of R is equal to square root of sigma square of R and is equal to sigma of R. And the standard error of the symbol mean by central limit theorem is sigma of R bar is equal to sigma R over square of n. If you took either statistics or probability before, the central limit theorem say that when the sample size is at least 30, or when the original population follows normal distribution, then the sample means will follow normal distribution with the same mean and with the standard deviation of sigma over square of n. So this is the central limit theorem. And the meaning of learning the standard error of the symbol mean is sometimes we want to see the variability of the symbol mean instead of specific value of the data set. So that's how we compute the variance volatility. Now we have a couple of properties of mean and variance that I believe these are important and essential for you to practice on the problems that relates to mean and variance. First, expected value of x plus a is equal to ex plus a. Here x is a random variable and a is a constant. Imagine like if the whole class, everybody got 2 points on the test. Like if the teacher give everybody 2 points on the test, then the average of the class should go up by 2 points. That is the meaning of this properties. Now expected value of a times x plus or minus b times y is equal to aex plus or minus bey. A and b are constants, x and y are random variables. And the variance of ax plus or minus by is equal to a squared variance of x plus b squared variance of y plus or minus 2ab covariance between x and y. This is basic knowledge in mathematical statistics. If you took exam P before, you should be familiar with this formula. This is from exam P, the exam of probability. Variance of x plus a is equal to variance of x. So when you consider variability, a constant a that add up to the random variable would not contribute to the variance. And the correlation coefficient between x and y is equal to covariance of x and y over square root of variance of x part of y. So these are the most important formula that you need to know in this lesson. That's why I said like for IFM, I suggest you to finish exam P and exam FM before you start IFM. Otherwise you're gonna be confused a lot about some concept that you have never learned before. So in this one, we have we reuse some formula that we have found in exam P already, right? All right, so that was it for the knowledge for wherever we need to know in this lesson. Now we're going to do some practice. And before we do some practice, I want you to know that the following exercises are just the core examples. In order to have the best practice, you have to find and work on more exercises that relate to this topic. First, let's look at the first problem. Calculate the expected return. Here we are given a table of 3 columns. The first column tells you the 3 stocks X, Y, and Z. And the second column is the investment value that you put in each stock and the expected return corresponding to these 3 stocks. So here we see that the investor invests $10,000 into stock X with the return rate 8%. $15,000 into stock Y with the expected return rate 12%, and $25,000 into stock Z with the return rate 16%. And we want to find we want to estimate the expected return, so we have to use the mean. However, you see that here we do not invest the same money into stocks. We invest $10,000 into stock X, $15,000 into stock Y, and $25,000 into stock Z. So we have to use weighted mean instead of the regular mean. So for this problem, we have to use weighted mean. So RP here is the mean, and I'm gonna take its investment value times its expected return, then add them together and divide by the total amount of money that we put into the 3 stocks. So we got 10,000 times 0.08, that is the expected return from stock X, plus 15,000 times 0.12, this is the second term is the second term in the numerator is the expected return from stock Y, and the last term 25,000 times 0.16 is the expected return from stock Z, and we add them together to find the expected return value, and then we divide by the total money we invested, which is 50,000. 50,000 here comes from 10,000 plus 15,000 plus 25,000, and we got the expected return here is about 13.2%. 13.2%. See there. Some people might think we take 8% plus 12% plus 16% and then divide by 3. You're gonna have a wrong number, the wrong answer, because we didn't invest the same amount of money into each stock. So we have to use weighted mean instead of the arithmetic mean. Alright, problem number 2. You are given a portfolio consisting of 2 stocks with equal market value. The rate of return of stock 1 has a variance of 0.09. The rate of return of stock 2 has a variance of 0.05. The correlation coefficient between the rates of return of the 2 stocks is 0.30. What is the standard deviation of the portfolio rate of return? So this question, they ask for the standard deviation. The standard deviation is basically the volatility, and here it is the square root of the variance. And for this portfolio, we have 2 stocks, right? Stock 1 and stock 2. And they said like we invest equal value into the two stocks. So we're gonna have 0.5 stock X and 0.5 stock Y. 0.5 stock 1 and 0.5 stock 2. That means 50% and 50%. So first we have to find the variance. Here I'm going to use variance of 0.5x plus 0.5y because we invest equal value into this portfolio. We have 50% into stock 1 and 50% into stock 2. So we use either x plus y, the whole thing divided by 2, or you can use 0.5x plus 0.5y. Now we use the formula that we had in the slide of the important formulas. Variance of 0.5x plus 0.5y is equal to 0.5 square variance of x plus 0.5 square variance of y plus 2 times 0.5 times 0.5 covariance between x and y. But the question gives you a correlation coefficient, so don't forget we also have the formula of the correlation coefficient. So this equal to 0.5 square var of x plus 0.5 square var of y. The first two terms we bring from the first slide down here without changing anything. Now for the last term, covariance of x and y is square root of variance of x, variance of y times correlation between x and y. Because correlation between x and y is covariance of x and y over square root of variance of x, variance of y. And now we just have to substitute the number into this equation to find variance of 0.5x plus 0.5y. So here 0.5 squared is 0.25. Variance of x is 0.09. 0.5 squared is 0.25 and variance of y is 0.05. And 2 times 0.5 times 0.5 square root of 0.09 times 0.05, and then the whole thing times with the correlation coefficient, which is 0.30. So we got 0.04506. But do not forget to take the square root for the standard deviation. Many people forget the last step and use this as the answer, and they ended up having the wrong answer. So the volatility here should be square root of 0.04506, which is 21.23%. So see that. So I repeat, standard deviation is just the volatility. So the volatility here is 21.23%. See that. Alright, next, problem number 3. You are given the following information about two sets x and y. Assess x, assess y. For assess x, the expected return rate is 12%, with variance of return is 0.30%. And for assess y, the expected return rate is 15%, and the variance of return is 0.35%. The returns of these two assets are known to be independent. This is important. Independent, then the covariance between x and y should be 0. James invests 40% of his money into asset X and the rest in asset Y. So 40% in X and 60% in Y. Determine the expected return of his portfolio. So for the solution, first we have the portfolio here is 0.4x plus 0.6y because we invested 40% into asset X and 60% into asset Y. Now the expected return here is we use a formula of the property of the expected value in the important formula sheet. We got 0.4 EX plus 0.6 EY, and it should be 0.4 times 0.12 plus 0.6 times 0.15, which is 13.8%. Here the question gives you independent. Usually the information independent will give you the information, the covariance and correlation, and usually it should contribute to the volatility and variance. When you calculate expected return, this information is actually irrelevant. Alright, so here the expected return of this portfolio is 13.8%. Next, number 4, for two risky assets X and Y and the risk-free assets F, you are given 3 assets. X, the current price of this one is 100, with the expected return rate is 10%. Variance of return is 3%. Y, 120, 12%, 7%, and F, $1,000, $1,000, 7%, and there's no variance of return because this is a risk-free asset. For a risk-free mean volatility is 0, and volatility is 0 mean variance is also 0 because the volatility is the square root of variance. So I repeat, this is a risk-free asset. That's why the variance is not given. The correlation coefficient between the returns of X and Y is negative 0.15. Negative here, by the way, negative here means they have the opposite relation. That means when X increases, Y would decrease it, and when X decreases, Y increases. Adam bought 10 units of X, 10 units of Y, and 1 unit of F today. Determine the expected return of his portfolio. Alright, so for this problem, we have 10 units of stock X with the price $100. So we invested 10 times 100, which is $1,000 into stock X. We invested 10 times 120, which is $1,200 into stock Y, and 1 times 1,000 is $1,000 into stock F. And we have to determine the expected return of his portfolio. So here we use 10 times 100x plus 10 times 120y plus 1,000f, and divide by the total of money we invested, which is 10 times 100 plus 120 times 10 plus 1,000, and substitute EX is 0.1, is Y 0.12, and is F is 0.07. We got the rate here is 9.8125%. So that is problem number 4. And again, the correlation coefficient here is irrelevant because the question wants you to find expected return. I repeat, correlation coefficient just contributes into the volatility and variance. Alright, problem number 5. You are given the historical prices of assets 1, 2, 3, 4, 5, 6, and 7 with the price 1,200, 1,400, 1,500, 1,450, 1,400, 1,600, 1,750. Estimate the mean rates of assets X using the simple mean return. For this problem, many of you might got it wrong. You take the average of the second column. You take all these 4 digits number, add them together and divide it by 7, which is completely wrong. Remember, in this lesson, we want to find the simple mean of the rate return. We have to take the RI from 1 to n, add them together and divide by n. Here we are not given RI. We have to find RI. We have to find the rates of the first year, the rate of the second years, and so on. So here, go back to the lesson in financial mathematics. This is in exam IFM. In order to find the interest, the effective rate in the first year, we take 1400 divided by 1200 and subtract 1. So here R1 is 1400 over 1200. Remember here 1400 over 1200 is 1 plus I, right? So when you subtract 1, you got the I. And this is, in this lesson we use R1 is the rate in the first year. The rate in the second year is 1500 over 1400 subtract 1. We got 0.0743, 143. And so on until R6. Here we don't have R7, okay? We just have R6. R6 is 1750 over 1600 subtract 1. So now we have 6 return rates, right? Representing for 6 years. So the expected return is the average, the arithmetic mean of these 6 numbers. And we got 0.0678, which is 6.8%. This is one tricky question, okay? I want you to write out this problem because this is a tricky question. Many of you got it wrong. Many of you to take the average of the price, but the question don't ask you for the price. They asked you for the simple mean rate return. All right. Next. Number 6, you are given the following data about a portfolio consisting of 2 stocks, stock A and stock B. Percent portfolio invested 50%, 50%. So we invested equally into these 2 stocks. 50% of our money into stock A and 50% of our money into stock B. The variance of rate of return is 0.09 for stock A, 0.04 for stock B. And the core variance of returns on stock A and B is 0.05. The question asks for the portfolio variance. So here we got variance of this portfolio is 0.5A plus 0.5B, right? And here we have, or you can write out 50A plus 50B over 100 the same way. Now we use the properties of variance. We have this is 0.5 square variance of A's plus 1.5 square variance of B plus 2 times 0.5 core variance of A and B. And core variance here is 0.05, right? So just put in the number. 0.05 squared times 0.09 plus 0.5 squared times 0.04 plus 2 times 0.5 times 0.5 times 0.05. And we got 0.0575, which is 5.75%. So this is the portfolio variance. And if the question asks for the volatility or the standard deviation, we have to take the square root. But for this question, they should ask you to stop at the variance. So 5.75% is the final answer. So those were some core problems that you're gonna see, you might see on the exam. So what have we learned after we finish this lesson? After we finish this lesson, I want you to be able to explain the mathematics and summary statistics of portfolio. You have to be able to calculate the risk and return of an asset. You should be able to calculate the risk and expected return volatility of a set of a portfolio, of a set of investments. So that was it. Thanks so much for watching my video. I hope you guys enjoy my lesson, and see you on the next video next Sunday by 7 p.m. Eastern Time. Bye bye.